welcome to this class. In this video, let us discuss about the Umpolung character of this 1,3-diethane, right? So what is this? So let us see this. So here I have taken aldehyde, and we know that this aldehyde carbon is there, right? So it is more electrophilic. More electrophilic. Electrophilic means let me show it by delta plus charge, right? So it is more electrophilic. So if I react it with 1,3-dithiol, right, this is 1,3-dithiol, 1 2 3 1,3-dithiol. So what I will get? I'll get this compound. So here sulfur will be there, here sulfur and other things as it is, right? So this is my diethane, 1,3-diethane, right? So here what you will see, again this carbon will be having delta positive, right? So it is electrophilic. Why it is electrophilic? As it is attached to two sulfur atoms which are electronegative, right? So it is electrophilic. To this if I add any base, right? So this is electrophilic, right? To this if I add any base like strong base N-butyl lithium, so it will be having negative charge, and this lithium will be having, so it will take this proton. So what happens? I'll get this product. See here, or it will be like this. So negative charge comes on carbon, right? So here negative charge comes means it is having delta minus. It acts as a nucleophile, right? It acts as a nucleophile. So here see Umpolung character. I didn't tell you the definition. What is this Umpolung character? Umpolung character is nothing but reversible of charge. So charge will get reversed. So reverse of charge happens. So what kind of reverse of charge? Here I explained it, right? So here it will be delta positive, right? So as soon as I add a base, strong base, it takes that proton and it becomes negative charge, that carbon. So it becomes nucleophilic like carbon, it became, right? Negative charge. So here reverse of charge happened, reverse. From plus it became minus, right? Further, if I react with like any RX compound, then what happens? SN2 reaction and I'll get this product. See here, let me write it. So I'll get this product. So here R is there and here one more R. Again if you see this carbon is there, right? This carbon will be delta positive as it is attached to sulfur, electrophilic, right? So further if you remove those sulfur, adding this HgO or Hg2 plus in presence of water, I'll get this ketone here, RCOR, right? And other things as it is. These things I have told the mechanism of this also, right? And it becomes HgOH twice, right? So see here, this carbon is there, right? So it is again electrophilic only, right? Because we have studied this ketone will undergo nucleophilic addition reactions, right? So it will be again electrophilic. So if you see only this 1,3-diethane, see here with green marker I am showing, just to see this, which I have marked a square box with green marker, right? So what happened? You can see here initially it was plus 1,3-diethane, it is plus, right? So plus. So further when I react with a strong base, reverse of charge happened and this carbon gets negative charge. Further when I do reaction with like SN2 reaction, again it became plus here, see, plus. So it is reverse of charge. Initially it was plus, some reaction it became negative, and from some other reaction it became positive. So this change in polarity, right? So this is nothing but I can write like, see here, just you mark star mark here, right? So this Umpolung means polarity inversion, right? So initially it was positive, some other reaction it became negative, from some other reaction it became again positive. What are that reactions that I have explained here above, right? So from aldehyde I synthesized this 1,3-diethane, which has got carbon which is positive, right? Positive means it will be electrophilic, delta positive will be there. So positive charge, let me write. So when I add this N-butyl lithium strong base, it will take that proton as I have shown here. So as soon as it takes, this negative charge comes on this carbon. So here negative charge is there. So from positive to negative, there is inversion of charge, I can call, or reverse of charge, right? That is nothing but Umpolung character. Further, what I will do, I will add this R dash X or methyl iodide. So here SN2 reaction happens. Because of this SN2 reaction, again reverse of charge happened, right? So this is how this reaction happened. So this is nothing but my Umpolung character of this 1,3-diethane, right? So this I wanted to tell, right? I hope you got it. So further, let us discuss few more reactions of this 1,3-diethane. So these are also easy, right? So let us see them. So I hope if I write like this, I think you are able to understand now, right, how I got this. To this I will add different reagents. See here I will add simply ketone. So what happens, this electronegative charge will attack this carbon as it is electrophilic. So I will get this product. See here, so here O minus, and here carbon to this R group is attached to this. Yes, it is 1 3, so 3 carbon, right? Further, HgO in presence of water, if I react it, I'll get this product. See here, it gets OH here, and here I'll get R and double bond O. So if you number it, so this is the functional group. So this alpha hydroxy ketone, I got, right? So this is reaction when we react this thing with ketone, right? So let us do different kind of reaction. Like I will make use of this thing, Cl, right? We call this as benzyl chloride, BzCl, right? Benzyl, Bz stand for benzyl, and structure is this one, attached to something. Here if it is attached to chlorine, then we call it as benzyl chloride. Simply we write BnCl, benzyl chloride, right? So here again it will do SN2 reaction. See, with red marker I will show, sorry, to this carbon it will attack. Chlorine is a good living group, it leaves the system, right? Not to chlorine, this I did wrongly, right? So it is SN2 reaction, simple SN2. And directly if I want to write product, this is SN2 reaction, right? SN2 reaction. Second step, when I add HgO in presence of water, directly I will write the product. See here, what product I will get. So this is thing here, CH2 benzene ring, here CH2 to this carbon and double bond O. I will get this product. I hope you will get the same thing, right? So because I have explained all those things in last class, so you need to write it. So other reagent if I add, here I have taken SN2 reaction, here I have taken nucleophilic addition reaction when we add ketone. Let me take one more example, like epoxide, right? So this is my epoxide. If you see, this carbon is hindered, whereas this carbon is less hindered. So if this nucleophile want to react with green marker, see, if this nucleophile want to react, it will react to this less hindered because it has to do SN2. I know that SN2 order is primary, secondary, tertiary. It means primary will react fast. It means less hindered. Primary means it will be always less hindered. So less hindered will react fastly, right? So this thing you need to understand. So what the product I'll get, see here, let me write here. So other things as it is. So second step, I am adding Hg2 plus in presence of water. So I am going to write the product directly. So here I will get OH to this carbon, this R group attached, and here I will get ketone, right? If you number, so this is the functional group for me, right? So if I want a number, it will be alpha, it will be beta. So I will get beta hydroxy ketone, I can write, right? So this is how, right? With different reagent, we used this reagent this time. Epoxide ring opening reaction happened, right? Further, if I make use of this carbon dioxide, simple carbon dioxide, so this carbon dioxide will be, this carbon will be electrophilic. So again this electron density will attack here, this will go out, right? So when I add HgO in presence of water, directly I will write the product. This thing you should be able to write now. So R here double bond O, this R attached to this carbon, here it has got OH, and here double bond O. So this is nothing but carboxylic acid for me. This is carboxylic acid. So this is functional group to this alpha. So I can call it as alpha keto carboxylic acid, or I can call it as alpha keto acid, simply alpha keto acid they are called, right? So this is how we synthesize different things using this same 1,3-diethane, right? So these were the 4 reactions, right? One more, can you write for this? See here, R C triple bond N. If I make this R dash, no problem. So then see, with this marker I will show this nucleophile will attack this carbon as it is electrophilic, as it is attached to nitrogen. Nitrogen is an electronegative atom. So if I want to write the product here, I will write directly R dash C double bond NH. I can show for this carbon is attached, which is attached to R double bond O. This product I will get. If I do further hydrolysis this, we know that this is imine like structure. Imine, carbon and nitrogen having double bonds, we call it as imine. For this, if I do hydrolysis, acidic hydrolysis, then this bond will be broken and I will get this thing, R dash C double bond O, again double bond O, R. So 1,2 dicarbonyl compound I will get, along with ammonia is liberated. As it is in gas form, it will be allowed to atmosphere. So I will get 1,2 dicarbonyl compound. I hope where I am writing you are able to see it, right? So this is how reaction, right? These simple reactions you have studied, so I didn't write the mechanism for them, right? So these were the few reactions, right? So let us see few more reactions. These are very interesting. See, so I have taken this 1,3-diethane. So this is my 1,3-diethane. N-butyl lithium, it will abstract this proton, so this carbon gets negative charge. So initially this carbon will be having positive, as it is electrophile, now it will become negative, so it is reversible of charge. So 1,3-diethane are good example for Umpolung character. Further, from this negative charge it will attack here like this. So SN2 reaction, I hope you know the product. So second step, HGO comma H2O. So now onwards I will write directly the product, right? So mechanism you know. So R C double bond O, and here one more C double bond O. Sorry. Here what I will get? I will get this thing. See here. From this it has R C double bond O, and here R dash comes. So I will get ketone. With alkyl chloride, here chlorine is a good leaving group. So I will get 1,2-dicarbonyl compound, CO, and here COR. So it is 1,2-dicarbonyl compound. I hope you know what 1,2-dicarbonyl compound means. Here one carbon, second carbon. So carbonyl group, here one group. So this is 1,2-dicarbonyl compound. So this is epoxide. So this ring opening you can do anywhere. Here also you can do, or here also you can do, as it is symmetrical epoxide, right? So as it is symmetrical epoxide, so I'll get this product R CO, right? One side ring opening happened, OH, here one R is there, here one R is there, right? So this is the final product. Everywhere second step will be, I have not written, so it is Hg2 plus in presence of water, right? Everywhere second step the same thing. I didn't mention it, but I have told you, right? So this one, so here this epoxide is there, right? So it is unsymmetrical. Here there is sterically hindered, and this carbon is less hindered. So this nucleophile is there, right? So it will attack this carbon which is less hindered. So ring opening happens and I'll get this product only. See, R CO from this carbon ring opening. So OH will be here and R will be here. So this product I will get. So if you number alpha beta hydroxy ketone I will get, right? For this similarly, let me write again, it is same thing. R here, negative charge, 1 sulfur, 2 sulfur, like this. So again it will attack to this carbon, this ring opening happens, and second step I add those things, mercury, so I'll get this product here. Here R is there, and here 2 methyl. So this is the thing I'll get, right? So these reactions you should know, right? So if a number, it is alpha amine group is attached, right? Alpha amine ketones we can call. So here what happens? So this is again, this nucleophile will attack this electrophilic carbon, so goes so I'll get RCO carbon to this R and OH. I hope you understand this, all those things. You please write the mechanism for everything so that it will be clear for you, right? So I have explained all kind of reactions involving this 1,3-diethane, right? So here let me take one more example so that I will make you clear. So here let me solve few things. So again I will add n-butyl lithium. So what happens? It will take this proton and I will get this product, right? So then what I have got this product, this compound, see, right? So it has got two ways. Here this nucleophile will attack here, this bond will go here, bromine can leave the system, or this can attack directly here and this bromine leaves the system. So this is called SN2 reaction, whereas this is called SN2 prime reaction. Which will happen, right? The answer is SN2 reaction will happen, SN2 prime will not happen. The reason is, see here, so here steric hindrance is lot, because of these two thing, steric hindrance, it is also hindered, this is also hindered, and here also because of these two things steric hindrance will be there, but here no steric hindrance, right? So it can easily attack here. So I'll get only this product, it will attack directly here and this bromine leaves the system and I will get this product, see here. So other things remains as it is. So it attacked directly here, this carbon which is attached to double bond OH. No, I should not write. So let me write all the steps here for this reaction, right? So what I'll get, see. So from this carbon, it attacked to this bromine. So bromine left the system. So double bond is here. This CH2 for this carbon is attached, which has got sulfur, and 3, like this, right? So this is the thing. Further what I will add mercury. So Hg2 plus, when I add, it has got lone pair, it will also attack, so let me write mechanism for this. I explained all those things, but here let me write. So sulfur Hg2 plus, now it becomes neutral, and 3 carbons here, like this, right? So sulfur gets positive charge as it is donated its lone pair. So what happens? Water will be there in the system. So water will attack here, this bond will break, sulfur becomes neutral, right? So I'll write the product, see here. Are you able to understand it? So water OH I'll write simply, and from this bond is broken, and Hg, it is attached to sulfur and 3 carbons, right? So this sulfur is positive, but this sulfur is neutral now, it got its lone pair. Further what happens? Again this bond breaks, this takes the sulfur and sulfur becomes neutral, right? So I'll get COH, right? Other things you have left with like this, S, Hg, S, and 3 carbons, right? So water will be there, water means OH will add here, I have told these things, OH will add here, H will add here, again here also OH will add here, H will add here. So I will get this product directly, SH, Hg, OH twice, right? So this is the product I will get, right? So we studied about this reaction. So here SN2 will be more compared to SN2 prime because of steric hindrance. In some cases when steric hindrance is not there, then there can be SN2 prime also, right? So I have one more interesting reaction. Let us see that. Let us see that oxygen, sulfur is having positive, oxygen is having negative. To this, yes, ethyl is attached, and here hydrogens, two hydrogens are there, and they are using LDA. LDA, we study about this LDA also, right? If you see that, so it acts as a base, so it will take this proton, right? So what I'll get, so how we add means LDA in presence of tetrahydrofuran we add at 20 degrees Celsius. So reaction will be going, so it, I have told it to act as a base and it takes that proton, so this carbon gets negative charge. Further what happens, here we add ethyl iodide. Ethyl iodide structure CH3 CH2I, so SN2 reaction, iodine leaves system, right? So it is simple SN2 reaction. So I'll get this product ET, yes, O minus, sulfur gets positive, SET, and here CH2 CH3, right? So this is the product. Further what they are adding, they are adding Hg2 plus in presence of water. I have told here Hg2 plus means it will react with these sulfurs, as sulfur were having lone pairs, so I'll get this product O minus sulfur plus, right, Hg, yes, Et plus. So same story, this mechanism we should not want to write. So directly if I treat it with water H2O, this water will attack here, this bond will break, this bond will break. Let me write the product directly, so I'll get this thing, right? So this product I'll get, right? So what it is, did I leave anything? I wrote yes, yeah, it's true. So I'll get this product, right? So this is how we do the reaction, right? So this is, we get this aldehyde, right? So these are the few reactions of this 1,3-diethane. In next class, let us see one more reagent, that is LDA, lithium di, what it is, so lithium diisopropyl amine. So this LDA we shall discuss about it, right? Till then, take care and have a